Assalamualaikum and good day everyone. We are from Group 3 for subject Statistic, code 23602. So first, let us introduce ourselves. My name is ARISSA FARHANAH binti NORIZAN, matrix number AA231916.
My name is KHALISAH MAISARAH binti KELANA, matrix number AA230194.
My name is BATRISYIA AIMI binti ABDUL RAZAK, matrix number AA231543.
The purpose of this video is to complete our group task. We got scenario 1, which is we need to investigate how the amount of water in a bottle affects the distance it rolls. So, let's get started.
Table, we have the facts, ideas, learning issues, and action plan. For the facts, firstly, we are testing how far a plastic bottle rolls depending on how much water is inside. Secondly, bottles are pushed on a smooth and flat surface. Lastly, water volume is varied in equal increments. Next, for ideas, firstly, more water might make it roll farther due to momentum. Secondly, too much water could make it roll less due to increased friction or instability. And lastly, there might be an optimal water amount. To really understand what's going on in this case, there are a few things we are still not sure about. So these are our learning issues. First, how does mass affect motion and rolling distance? Second, how do we calculate and interpret a regression line? And third, what variables should be controlled to ensure a fair test? And lastly, for action plan, first, we have to set up a controlled experiment with consistent pushing force and surface. Secondly, collect at least 10 sets of data for different water levels. Third, use MATLAB for linear regression and plotting graph. And lastly, refer to any statistics book from UTM library and reliable websites for regression concepts.
This is our problem background. We wanted to find out how the amount of water inside a bottle affects how far it can roll. The idea is that adding more water increases the mass, which could help improve momentum and allow the bottle to roll farther. But there's a catch. If the bottle becomes too heavy, it might become unstable or experience more friction, which can reduce how far it rolls. So, we tested different water levels step by step and used MATLAB to analyze the results. Our goal was to understand how mass influences the efficiency of motion during rolling.
The materials that we use are water, measuring cup, measuring tape, bottles which same size and shapes, and also we need to have paper and pen to record all the data. First, we need to fill in the water in this measuring cup with 50 ml of water. Then, from the measuring cup, we put in the water in the plastic bottle. Then, we do the same steps for the other amount. Push the bottles on a smooth and flat surface. Measure the distance bottle from starting point. Record data for the measured value. Repeat until third attempt for the water mass. calculate the average value. Lastly, repeat the same process for the remaining mass.
Here is the result for our experiment. As you can see, at 50 ml, the bottle rolled only around 30 cm due to low momentum. When we increased the volume to 200 ml, the distance increased to over 100 cm, showing improved momentum. The maximum distance, about 130.8 cm, was recorded at 400 ml, which seems to be the optimal point. Even at 450 ml, the bottle still rolled further, but the increase slowed down. In conclusion, adding water improves the rolling distance due to more momentum, but after a certain point, the effects become smaller.
Now, let's move on to the calculation part of our regression analysis. To understand the relationship between water volume and rolling distance, we use simple linear regression. First,
we collected data for 10 trials with water volumes ranging from 50 ml to 500 ml and calculated the mean rolling distance for each. Next, we calculated key statistical values. The total of X values, which is water volume, is 2750. The total of all Y values, which is the mean distance, is 1002.1001. The total of X square is 962500. Then the total of Y square is 110,518.5658. And the total of X multiplied by Y is 317,400.015. From this, we calculated the mean of X, which is 275, and the mean of Y, which is 100.21. Then, we calculated the variance and covariance for the total of XX, which measures how spread out the X values are, is 206,250. The SYY, which measures how spread out the Y values are, is 10098.1048. And then, the total of XY, which measures how X and Y vary together, is 41,822.4875. Using this, we calculated the slope of the regression line. For beta head 1, or the slope is SXY divided by SXX, then equal to 0.2028. Next, we calculated the intercept. Beta head 0 is the mean of Y minus the slope times the mean of X. That gives us 44.44. So, the regression line equation is Y head equal to 44.44 plus 0.2028x. This means for every 1 ml increase in water, the rolling distance increased by about 0.2 cm on average.
To determine the coefficient R square, we have to use the formula SSR over SYY equal to 1 minus SSE over SYY, and we got the answer of the coefficient is 0.8399. This result means that 83.99% of the change in rolling distance are caused by the amount of water in the bottle, showing a strong connection between the two. The other 16.01% may be affected by things like surface friction, differences in how bottle was pushed, or water moving around inside the bottle.
In the end of this experiment, we can conclude and observe that the mass of the water affects the distance of the bottles it rolls. Besides that, we can conclude that too much water make it roll less due to instability and friction.